Welcome. This video covers column manipulations using dplyr. The major column manipulation that we're going to look at in this particular video is the idea of subsetting your columns. And we're going to refer to that as selecting the columns because the select function is the major function that we're going to use to do this. However, we have already seen a little bit how we can pull down some columns. We've seen some base R methods. So these two here, these are base R ways of doing things. But they don't really fit the syntax of the tidyverse, and they don't allow us to write code that's all sort of coherent and easy to read. And so we're going to stay away from those as much as we can. However, whenever we do want to pull a single column off of a tibble, remember that they don't simplify. And so if we want to stay in the tidyverse and pull off a single column, we can use the pull function. Here, what we're going to do is read in that layman package so we gain access to some baseball data. I'll read in the dplyr package so I gain access to the pull function without having to call it specifically from that package. I'm going to create my batting object, which is a tibble form of the batting data table or data set from the layman package. And now I'll use pull to say I want to pull from the batting tibble the x2b column. And again, that simplifies that column into a vector. All right, let's suppose that we want to return more than one column. Well, we can use this select function. And what's nice about staying in the tidyverse is that the functions have similar syntax. So we give it the tibble as its first argument, and then whatever actions for that function after that. For instance, I can use select on my batting tibble and say I want to select from that thing the x2b column. And this is going to return a tibble version of just that column. If you want more than one column, you just separate with commas the columns that you want using their column names. And so sometimes you're going to want to put together multiple function calls, right? I might, as we did in the previous video, we might want to filter our data set. So I'm going to filter the my batting object. And then from that, I'm going to select just a few of the columns that I want to work with. And from the result of that, I might want to then arrange the column, rearrange the rows based off of one of the columns. And so you can see that this is actually kind of hard to read, right? This is the first thing that you need to look at. The result of that function call is then what tibble we're going to work on for this. And then finally, we have the arrange function coming last. And so traditionally, you have to read your functions from inside out if you use multiple functions on one line. And that can be really difficult. So instead, the tidyverse has really popularized the idea of what's called chaining or piping. And it's a new operator that comes with the dplyr package or the magrittr package. And this is the % greater than % operator. And what this allows you to do is write code that goes from left to right rather than starts in the middle and then you have to nest and then you have to parse on the way out. And so the way that you read this % greater than % is just as the word then. So what we're going to say here is take the my batting data and then filter it based off the team ID being Pittsburgh. And then with the result of that, select just these columns. And then with the result of that, arrange based off of this column. And so what this % greater than % does is it just takes this right here and it makes it the first argument of this function. And it takes the result of this right here, so the result of the filter call, and it makes that the first argument to select. And so it just makes your code much more readable rather than having to nest your functions. You can read them from left to right. And so generically, if you were looking at what piping is doing, if you do x pipe f of y, this is really just saying that x is going to be the first argument to that function. And so if we do x, then f of y, then g of z, x becomes the first argument to f, but then f of xy becomes the first argument to g, as you see over here. So that's exactly how we wrote our code before, right? We had to nest it. This is just allowing us to write it in a different form. And since all the tidyverse functions are meant to work in sort of the same way with the same syntax, the tibble always goes first, right? Pretty much. And so what we're going to be able to do is just chain from left to right all of the functions that we're going to use from within the tidyverse if we want to do more than one function at a time. And it's a fantastic way to do your coding. Again, so this is what I just mentioned here, that we're going to have the same syntax that the first argument to all of these functions in the tidyverse is going to be a tibble. So as long as I'm starting with a tibble and that function produces a tibble on the back end, I can keep chaining and chaining and chaining. So almost all of these functions are going to return a tibble, even if they do it sort of invisibly. All right, so let's see how we can write our code using chaining to make it more readable, and also look at some of the more other functionality of the select function. You can grab all columns between two columns in your data set using this colon operator. So here I'm going to say take the mybatting data set and then select all columns between x2b and hr. So there just happens to be only one column between there. I can use some other functionality from select, such as contains. So I can say from the mybatting data set, then select any variable that contains a capital X. And so there's two of those, x2b and x3b. I can say grab any variable that starts with a capital X, and then maybe any variable that starts with a capital X or ends with an ID or is the games variable. So again, this select function gives us this great functionality for selecting multiple columns. Doing this in base R is not very easy. Doing this with the select function is very, very easy. And then if you just want to sort of reorder your columns, like there's two columns that you just created at the end of your data set that you want to put as the first two columns so you can sort of just see them when you're printing it out, you can do that using the everything function. So what you do here is you just say mybatting, then select the columns that you want, and then just put everything, this function here, and it will grab every other column that you have not already specified and put those afterward. All right, so that is the select function, great for selecting your columns. The other major column manipulation we're going to cover here is just renaming your columns. So for instance, we had this x2b and x3b variable, and those two are kind of confusing if you don't know much about baseball, but that's the doubles variable and the triples variable. And so we might say, take the mybatting data set and then select any variable that starts with x and any variable that ends with ID and the games column. With the result of that, then rename the x2b column as doubles and the x3b column as triples. And so we get a resulting tibble that's a little bit easier to read. All right, let's jump into R and utilize some of these column manipulations. All right, here we are in our studio. We're going to continue the previous program we were writing. And so we left off, we had just sorted the data by fixed acidity, but we had to do it in this weird chaining, or in this weird nested way that's kind of hard to read. Let's just start by rewriting this code in a little bit better way. Make sure that we can understand how chaining is working and make it more readable. The first thing we want to do here was filter. So we're going to go ahead and start with the wine data object, and then % greater than %. The good programming practices says to, after a chain, just drop down, hit an enter, and drop down to the next line. And so from here, we're going to say filter based off of these things. So we're going to put that there, but we need to remove that first argument, wine data, because that's going to be coming in from the chain. So we're going to get rid of that. And so now we just need to specify the filtering options that we want. We can go ahead and run this code just to make sure it works. So we run that. It didn't give us an error. Looks like it worked just fine. And so we'll say chain. So then go ahead and arrange. That was our next one. And we're going to arrange descending on fixed acidity. And this should give us the same exact tibble that we had before, arranged by fixed acidity. But again, this code here that we see is much, much more readable than the code that we see up there. So chaining is wonderful. Chaining is great. All right, let's do some column manipulations. Let's go ahead and just select a few of the columns, just the ones that are based off of, say, well, actually, let's first rename some columns because, again, we have this weirdness to these names. These are non-standard names. They have spaces in them. Let's go ahead and just look at the names of the wine data. So those are all of our column names. I'm going to go ahead and rename some variables. So I'll put in a code chunk. We'll go wine data, chain. We're going to rename. We're going to give it the quoted string that we want the new variables to be named. So I'll just do fixed acidity. I'm going to use lower camel case. Oops, acidity. And then we'll say equal. We got to give it the backticked version of the name because that's how it's currently stored. Fixed acidity. We'll also do volatile acidity. Volatile? I don't know. And so I'll go through and do a few more of these. All right, so I've finished typing all of that out. I've renamed all the variables that were sort of special with a lower camel case version of those. Let's just run that. Oh, I got an error. So I spelled something wrong, it looks like. Nope, sulfur is not spelled with an A. Let's run that again. And so now we have new variable names here that are better. They don't require those backticks. And I'm going to go ahead and overwrite this wine data set, but I'm going to call it my wine data just to make sure that I don't accidentally do something funky with the original data. And now I'll run that and I'll get a new object called my wine data. Hooray. Okay, so we've renamed our variables, created a new data set based off of that. Let's go ahead and do some chaining. We're going to grab what we did up here, and we're going to just filter some of the, we're going to subset some of the columns. So now subset some columns of the new wine data set, which is called my wine data. So again, I'm just putting in code font here, just for the fun of it, using those backticks. So I'm going to take what we had previously, I'm going to replace wine data with my wine data. Got to be case sensitive, so we'll do that. We'll take what we did there, we'll add a chain to it. We'll say after you've already done that filtering, after you've already done that rearranging of the rows, then let's go ahead and select from that just the columns that end with, so we'll do ends with, and then we'll put acidity. And let's also grab the type, well, type's all red here. Let's also grab the alcohol column as well. Fixed acidity not found. Oh, right, so we're using my wine data, so I have to fix these because we no longer have that in our data set. So we'll go fixed acidity. Fixed acidity. Now we'll run that. Okay, so now we have the fixed and volatile acidity and the alcohol variable. Now we've done some column manipulations on our data set. All right, to recap, dplyr is still giving us this great functionality to do data manipulation. In this case, the select and rename functions for playing around with columns. But not only that, this chaining operator gives us a way to write much more readable code, especially for people that are not used to looking at code. Being able to read from left to right simplifies things for a lot of people.